Let's take a look at an example of special factorization. Anytime we're trying to factor an expression, we want to see if the terms have any greatest common factor. And if so, let's take that GCF out. But these terms don't share anything. But I do notice one thing that's a little unique about them is that they are both perfect squares. Now, what do I mean by perfect squares? I mean that if you were to do a tree for the 25x squared and then do a tree for y squared, you'd see something unique that you don't always see. You would see that every factor that we come up with has a partner, which means that the original expression is a perfect square. All it means is that the 5 has a pair and the x has a pair too. So that means if we were to go and take the square root of the 25x squared, we would actually get 5x because 5x times itself makes 25x squared. I can do the same thing with the y squared. It's a little easier here. The square root of y squared is simply y. Now, why does it matter that these are perfect squares? Well, there's actually a known form of a factorable expression that says if you have a difference of two perfect squares, then it will be factorable. It'll factor into the terms, the factors a plus b, a minus b. All right, so that's what we want to do with our expression. We want to break it up into two binomials, something plus something, and then something minus something. But what goes there? We need to put a into that first spot. So what is a here? Well, notice that 25x squared is in the place of a squared. So if a squared is represented by 25x squared, then that would mean that a would be 5x. And that's what goes here. Because 5x times itself will make 25x squared, and that'll be the first term. Now, we also need to find out what b is, and whatever that is, we put that in last. So, as you can see, b squared is in the place of the y squared. So b is going to be just y, and that's what goes here. Now we could prove that this final result really is equivalent to the previous simply by foiling. And if you FOIL that, you'll find that the middle terms cancel. You'll get 25x squared when you do the firsts. If you do the outers, you'll get minus 5xy. And if you do the inners, you'll get plus 5xy. See, those will cancel. And then you do the lasts, and you'll get minus y squared. So these ones cancel. And it works.